Hello, in this video we're going to talk about scalar multiplication. A scalar, if you remember from your vector talk, a scalar is just a single number. So you compare a scalar with a vector. Here we're comparing a scalar with a matrix. A scalar is that single normal number. And the matrix is of course our 2 by 2 matrix here. Scalar multiplication is the easy type of matrix multiplication. It's just multiplying the matrix by a scalar. And we classify it because we have scalar multiplication and then matrix multiplication. Matrix multiplication has quite a bit more steps to it. It's a little more complicated. Sort of like with vectors, the difference between scalar multiplication and the dot product or the cross product. And actually, interestingly, matrices are often used to store vectors. So you can put a vector into a matrix. So this would be one vector and this would be another vector in my 2 by 2 matrix. So just interesting how they both have then that scalar multiplication and then the special type of multiplication. There's a reason for that. So scalar multiplication is just distributing in whatever is multiplying the matrix. It results in a same matrix, a 2 by 2 matrix, 2 by 2, and you just distribute that 3 to every term inside. So we go 3 times 4, 3 times 5, 3 times 6, and 3 times negative 4. And then you do all the multiplications, 12, 15, 18, negative 12, and there's your new matrix. So scalar multiplication, pretty easy. You just distribute in your scalar to every entry. Okay, so we'll try another example where it's formatted a little differently. It says find negative 2a, and it gives us two matrices, an A and B. Both are 3 by 3 matrices. So negative 2a just means negative 2 times the A matrix. Now these are both square matrices because they have the same number of rows and columns. But scalar multiplication works with any dimension matrix. It does not have to be square. Okay, so negative 2, I just multiply all of these by negative 2, giving me negative 4, negative 8, 6, 0. Negative 2 times negative 1 is positive 2. Negative 4, negative 2 times 1 is negative 2. And lastly, negative 6. And there's my resulting matrix. Okay, let's try example 2. Now it's saying find 3a plus 2b. So we first have to go 3 times matrix A. So I'll write that here. And then we have to add to it 2 times matrix B. 2. And you notice that notation, 3 capital A plus 2 capital B. That capital letter is often used to notify a matrix when you are dealing with matrix problems. So the first thing we do here is we'll go through and distribute, do the scalar multiplication. So I get 6, 6, 12, negative 9, 0, 3, 6, 3, 9. Plus now that B matrix, negative 4, 8, 6. So we'll distribute to every term. Every entry gets multiplied by 2. And now I add them. And remember, if you add, you do have to have the same dimension. So in this case, we have a 3 by 3 and a 3 by 3. So we are A-OK to add. So we add terms in the same entry. So 6 plus negative 4 is 2, 6 plus 8 is 14, 12 plus 6 is 18, and so on. We'll keep adding these. Negative 15, 0 and 20, 3 plus negative 4. On to the last row, 6 plus 6 is 12, 3 plus 2 is 5, and 9 plus 14 is 23. And here's our final one. So we did the scalar multiplication first in this problem, and then we added them together, making sure the dimensions of the matrices were the same, because you can only add or subtract matrices if the dimensions are the same. And since they're both 3 by 3, we were great to proceed.